Welcome back, everyone. Hopefully, based on our discussions in Activity 4.1a, Parts 1 and 2, you are now convinced that when you are selecting a sample to be representative of a population, you need to use randomness in that process. We are going to, today, or in this video, we are going to discuss in detail our definition of a simple random sample and go through some examples of that. But we're also going to look at situations where we might get a better representation of the population by using a method other than a simple random sample. So before we get started, I want to go over the objectives, and the objectives for this activity are the following. We want to be able to distinguish between a simple random sample, something called a stratified random sample, a cluster sample, a systematic sample, and a convenience sample. We want to recognize the advantages and disadvantages of each sampling method based on the situation. We want to describe how to use a random digit table to select a simple random sample, also known as an SRS. And we want to describe how to use various sampling methods to select a sample that's representative of the population. So to begin, we're going to pop back to Activity 4.1a, Part 2, and take a look at the definition of a simple random sample. In our book, it's basically stated as Part 2, all groups of subjects have an equal chance of being in the sample, and looks like we're missing something there in our notes. I think it says n greater than 1. Basically, any sample size n greater than or equal to 1 has to have an equal chance of being selected. I like breaking this down into two parts. The first part being n equal to 1, so each subject has to have an equal chance of being selected, and then the second part, all groups of subjects have to have an equal chance of being selected. But often books just put that together in one single statement. So let's take a look at an example here. So when we're selecting a sample from a population or an experiment, or for a survey or an experiment, sometimes a simple random sample is not the best way to do things. So we're going to take a look at a few examples, and we're going to decide what kind of sample that we have. So in our first case here, it says, suppose you want to survey high school students to determine the average number of hours per week students spend doing homework. You decide to select 30 students from the entire student body to participate in the survey. You assign each student in the school a unique number, and then using a random digit table, you select the 30 students. So a couple things about that. First of all, it appears that the population of interest is the entire student body, and we want to select from that. So even though it's not mentioned here, we would have to make sure that when we assign the unique numbers to every student in the student body, we would assign the same number of digits. So let's assume, for simplicity's sake, that there's 750 students in the entire student body. Then we would use triple digit numbers to assign to each of them, and then we would read off 3-digit numbers one at a time. And if we use the 3-digit numbers 001 through 750, we would make sure we ignore any other 3-digit numbers like 000 or 825 when we're selecting our sample. And we would also ignore repeats. So the first part of this question says, does the selection represent a simple random sample? And the answer to that question is yes. It does represent a simple random sample, because if we assign each student a unique number, let's say a 3-digit number, and there are 750 students in our student body, for example, then each student will have a 1 out of 750 chance of being selected. The next part of the question is, does each group of 30 students have an equal chance of being selected? And the answer to that question is yes, and that might be a little bit hard to justify right now, but you'll see why some examples in a moment lead to situations where that is not the case. The second part of this question asks, is it possible that the 30 people randomly selected do not represent the student body well? Well, if you remember, my randomly selected 5 rectangles had an average area of 2.8 when the true average area was 7.4. Well, my randomly selected sample was not a good representation of the population. But again, that does not mean that it is a biased method that we're using. So let's take a look at this next situation in B. Suppose you know that the distribution of students at a high school is as follows. 15% of students are in honors classes, 60% are in the regular level classes, and 25% are in G classes. How could you use this fact to help you design a better sampling scheme that will guarantee adequate representation of all 3 of these groups? So if you think about this situation, what you'd really like is your sample to have a makeup similar to the population. In other words, we would like about 15% of our sample to be honor students, 60% to be regular level students, and 25% to represent students in G classes. So how could we do this? Well, one way we could do this to guarantee a distribution that is similar to the population makeup is to break up the population into 3 distinct groups, often called strata, and then take simple random samples from each of those. In our situation where we're going to select a sample of size 30, this would not work exactly perfectly. In other words, 15% of 30 is 4.5. You can't select a sample of 4.5 students. But if we decided to increase our sample size to, let's say, 100, then we could take 15 students randomly selected from honors classes, 60 students randomly selected from regular level classes, and 25 students randomly selected from G classes. This incorporates randomness, avoids bias, and guarantees us a sample that should be representative of our population based on those proportions. This method is called stratified sampling or stratified random sampling. We break the population into distinct groups based on some criteria, and then we randomly select students or subjects from each of the groups. So the last part of this question is whether or not our stratified random sample could be considered a simple random sample. So imagine we have 100 students, or we're going to take a sample of 100 students, and we've broken the population up into groups based on the makeup of the types of classes that they take. So 15% are in honors, 60% are in regular, and 25% are in G classes. And we're going to take a simple random sample of 15 students from the honors track, 60 students from the regular level, and 25 from the G level. While each subject has an equal chance of being selected within their group, not all groups of 100 have an equal chance of being selected. And here's how that works. If you think about it, if you're going to take a sample of 100 students from the student body that we assumed was 750 students, for this to be a simple random sample, all groups of 100 have to have an equal chance of being selected. But if we follow our method, we are only going to get 15 students from honors classes, 60 from regular level classes, and 25 from G classes. Now, there are a lot of groups that can be made up that way that follow that criteria, but not all groups of 100 have an equal chance of being selected. Any group that's made up of 15 honors students, 60 regular level, and 25 G level have a chance of being selected. But a group that consists of, let's say, all honors students, all 100 honors students, or all 100 regular level, or all 100 G level students, those have no chance of being selected, and therefore they violate the criteria for a simple random sample. There are other sampling methods other than simple random samples and stratified random samples, and one of them is called a cluster sample, and number 2 illustrates that. So let's say that we have a large high school, has 600 senior students, all of whom are enrolled in 24 different academic study halls. Each study hall has 25 seniors in that class, and the administration wants to survey 75 seniors at random. So to do that, they decide to randomly select 3 of the senior academic study halls and survey all the seniors in these study halls. Now, what you notice here is that even though the seniors were broken up into 24 distinct groups, the method did not randomly select some students from each group. It selected entire groups. This is called cluster sampling. It is not a random selection method. It is a random selection method if the entire groups were randomly selected, but it's not a simple random sample. And the reason being is that we violate the criteria, is that not all groups of 75 students have an equal chance of being selected. And here's an example of that. Let's say we make up a group of these 600 seniors that consists of a few students from each study hall. Well, we could make up a sample of size 75 that way, but that sample has 0 chance of being selected because of the way we're doing this. The way we're doing this is we are selecting entire groups of study halls. So the only groups that have any chance of being selected are those that consist of all students in a particular study hall. So under some conditions, a sampling method like this, cluster sampling, is a good idea, but we have to ask under what conditions that would be. So in this case, this would be a good sampling method if we could say that each of the study halls was a good representation of the entire population, which of seniors, which that may be the case, but it may not be the case. In part B, we're asked under what conditions do you think this selection method may result in 75 seniors that do not represent the entire population of 600? Well, if those study halls or any of those study halls are not representative of the entire population of 600 seniors. So for example, let's say the study halls were segregated by GPA or gender or tracking, honors, regular, G level, or maybe it's an academic study hall versus a group of athletes. In any of those cases, it would not be a good way to select a cluster sample that is representative of the entire population. Again, this is called cluster sampling. It is often confused with stratified random sampling because in both cases the population is broken up into different groups. The difference being, in a stratified random sample, a simple random sample is taken from each of the groups. In cluster sampling, entire groups are randomly selected for the sample. In this case, the clusters are the 24 study halls. Another method of selecting a random sample is called a systematic random sample. So let's take a look at this scenario. Suppose we wish to get a random sample of 100 people who live in Hinsdale. A recent estimate indicates that there are 17,126 residents in the community. To select 100 residents, we would get a Hinsdale phone directory and randomly pick a starting individual in the directory. For the purpose of this problem, we're going to assume that all the residents are listed in the phone books, which I know is not the case. We could then move on, so we randomly pick a starting individual in the directory. We could then move 171 names further into the directory. Let's assume we're doing this alphabetically for the next person selected. From that person, we move another 171 names further into the directory, and so on until we have 100 people selected. The question asks, would this sampling method be considered a simple random sample? Well, it's random because we randomly selected our starting point, but it's not a simple random sample. And the reason being is that we basically violate the second criteria. Well, so let's say we randomly select the starting point. That means that every subject has an equal chance of being selected, at least initially. But once we select that first subject, nobody other than people that are multiples of 171 beyond them have an equal chance of being selected. So now not all groups of 100 have an equal chance of being selected. The only groups of 100 that have any chance of being selected consist of people whose names are 171 apart within the phone directory. A group of 100 that would consist of 100 people in a row, for example, has zero chance of being selected. The second part of this question says, under what conditions would this systematic sample method yield a representative cross-section of Hinsdale? Well, if you think about it, there are a lot of people in Hinsdale that are part of the population of Hinsdale that do not have phone numbers listed in the phone book. So right away, we are excluding all of those people as subjects in our sample. So I would say there's no chance that this would result in a sample that's representative of the entire population of Hinsdale. And again, this is referred to as systematic random sampling. Basically, we take our entire population, we write out a list of the subjects in the population, we pick a random starting point, and then we systematically go from that starting point to the, let's say, 100th person after that, or every 200th person, and so on and so forth. We want to finish up this lesson with an example of a sampling method that is often used but shouldn't be. It's called convenience sampling, and if you as a student have ever been asked to do a survey and you did not use a random sampling method, then you probably used a convenience sample. And convenience samples can take place in various ways. Maybe you're doing a survey of students as they walk into the cafeteria and you decide to select the first 10, or you decide to select every other one, or something like that. As you know, the random rectangles activity that we basically did a convenience sample before we used the calculator to select the sample for us. And there's lots of examples of that. So what I'd like you to do right now is pause the video, or before you end the video, think of some examples of convenience samples that you have witnessed. All right, well, hopefully you could think of at least one example of a convenience sample, and you could think of or relate that to how that leads to bias in your sampling or your sample. So we're going to stop here for today, and we'll pick up with number 5 in the next video. The second part of this activity, we are going to describe the situations below and whether or not that sampling procedure is a simple random sample, stratified, or cluster sampling. And then we're also going to practice describing how to take a random sample using various methods.